Once we have an understanding of what similarity is, our next progression is to figure out how to prove triangles similar. In triangle congruence, we had 5 methods. For similarity, we're going to have 3, and those are the 3 we have listed here. First up, if we have angle, angle. Now, we don't need all 3 angles, because technically if 2 sets of angles are congruent, the third set will be. So we're just going to say angle, angle. So I need angle A is congruent to angle D, and B congruent to E in this scenario. If I get 2 congruent angle pairs, then I have 2 similar triangles. So ABC is similar to DEF. Now, remember, this is angle congruence, so they could be labeled as congruent. I could have values that show they're equivalent. I could have maybe alternate interior angles or corresponding angles and vertical angles to show to it, but we just need to get 2 angles. Also to be noted here, there's no sides. If I have side values, I'm probably not going to use angle, angle. This would only be with angles. Side, side, side is next. And side, 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 for similarity, we have corresponding sides are proportional, and that's what we have set up here. So if you can match AB over DE, BC over EF, and AC over DF, and they're all equivalent to our scale factor, or a scale factor exists, that will be enough to show that the 2 triangles are similar. This one is going to come up when we know all 3 sets of sides in each triangle. Because remember, these are our numbers we have to have. This is not congruence. We have to know those values to show the values work to be a scale factor. You also won't typically have angles in side, side, side because you don't need them. The third option is side, angle, side. Side, angle, side, the same way it worked with congruence is you have to have an angle pair, so in this case A and D, and then you have to have 2 sets of sides proportional. Now I put these little squiggly lines, look like the similar here. This is not proper notation, but I want to show that it's the idea of saying 2 sides meet and it's the angle between. Angle, side, side is not going to work here either. It has to be in this proper order of side, angle, side. If it meets that condition, then we're going to have similarity. So we're going to go through kind of each set and see a couple of examples of each and proving that their triangles are similar. So let's start with angle, angle here. Now I'm going to list off the reasons, kind of informal 2-column proof. When you do a 2-column proof, we want to be a little bit cleaner, but I want you to see where we're going. So first off, I can say that angle C is congruent to angle G because I have parallel lines, as well as D is congruent to angle F. Both of these are congruent because alternate interior angles are congruent. So parallel lines lead to alternate interior. So if I label that here, technically that is enough for similarity. But we could have gone with the option of the vertical angles. So that would have been angle CED is congruent to angle GEF because they are both vertical angles. And vertical angles are congruent. Actually, 2 of those 3 would have worked. That would have been the minimum to meet that triangle CED is similar to triangle GEF by angle, angle. You only need 2. Okay, let's go to our next one off to the right here. First off, I have angle L. Angle L is in both triangles, little triangle, big triangle, and it is reflexive. This is what reflexive looks like with angles, and reflexive property tells us they're congruent. So that's the first step. Now with these parallel lines, we're not going to get alternate interior. We're going to get the other type we commonly see, and that is corresponding. So that would be angle M is congruent to angle, got to use 3 letters, PQL, as well as angle N is congruent to angle QPL. And again, both of these are because they're corresponding angles, and corresponding angles are congruent. So we show it there. This time we have, again, 3 angle congruences. You technically would only need 2 to show similarity. So let's say triangle MLN is similar to triangle QLP by angle, angle. So let's go down to side, side, side. For side, 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 we have to show these sides are proportional. We have to show we exist a scale factor. Notice here we don't know any angles. We don't need them. So we need to show we have equivalent fractions. So first off, 12 over 43.2 is 2 matching sides that we have. then I'm going to go 15 over. So let's see, we could do 15 over 18 and 5 over 54, or 15 over 54 and 5 over 18. We have to make sure we set up to the values that work, because if we pick the wrong values, we may get falsely that they're not similar when in fact they are. Now I'm going to think of this as like a mirror image, like it reflects over. So I'm going to go 15 over 54 equals 5 over 18. At this point, we have to make sure all of those fractions are equal. And there's a few different ways to do that. First off, I know that 15 over 54, if I divide them both by 3, it comes out to be 5 over 18. So that one checks out. 12 over 43.2 is a little bit different. So maybe we look at that and say, all right, let's change the fraction. I could make this 120 over 432 and then start to reduce it down, and eventually it does in fact get to 5 over 18. Another way you could do that is you could do 12 over 43.2 in your calculator, which comes out to 0.27 repeating, and then you could do 5 over 18 in your calculator, and that comes also out to 0.27 repeating, and that just verifies that they are the same value. There's not a lot we do here. We need to show what the scale factor is and ensure that they reduce down, but it's just confirming that all the values are equivalent. Once we have that, it works. We could say triangle ARP is similar to TRY, and that's by side, side, side. The next one off to the right, we have to think of it as little triangle, big triangle, and the important part we notice here, let me clean up some values, is the total side length needs to be added together. So it's 21 and 28. So I want to go little triangle, big triangle. 15 here is to 21, as 20 is to 28, as 40 is to 56. So I have fractions here that are all reducible, so let's go through and reduce and see if they all come out equivalent. 15 over 21, I can divide both by 3, and I get 5/7. 20 over 28, I can divide both by 4, and I get 5/7. 40 over 56, I can divide both by 8, and I get 5/7. They all equal the same value, so that is our scale factor. So that shows that triangle WXV is similar to triangle WYU by side, side, side. Next, let's go to side, angle, side. In side, angle, side, we need to first make sure we have our angles taken care of. So angle SER is congruent to angle GEF. Reason being is vertical angles. Then I need to set up my sides to show that they're proportional. So 6 is to 24. We go 6 to 24 as 12 is to 48. Now, these both reduce to be 1/4, so I'm going to say triangle SER is similar to triangle GEF by side, angle, side. Our next one, we have angle L being reflexive, but let's look at the sides to make sure they work. Now keep in mind, this is 39 and this is 34. So I have 30 is to 39 as 27 is to 34. 30 over 39, well, I can divide them both by 3, and that gives me 10 over 13. But 27 over 34 does not reduce. So I'm stuck here looking at these two fractions that don't appear equivalent. You could also go in and do cross product. So 13 times 27 is 351. 10 times 34 is 340. They're not going to be the same value, so if it's not equal, we're just going to say not similar. You don't have to go off and now try side, 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 or angle, angle. Once it fails this test, we know it's enough to say not similar. Next problem. I have parallel lines and I have then corresponding angles. So angle CMP is congruent to RPQ because they are corresponding angles. Now, let's see what sides we have. And since I have those angles and I have two sets of sides, I'm probably looking to make this work as side, angle, side. So we're going to go 54 is to 33 as 36 is to 22. Now 54 and 33, it looks like I can divide them both by 3. And if I do that, I get 18 over 11. 36 over 22, I can divide both by 2, and I get 18 over 11. So it works, they match, they are proportional. So we're going to say triangle CMP is similar to RPQ by side, angle, side. In our next problem, we don't know any sides. So if this is going to work, it's got to be angle, angle. I'm going to start with finding this angle right here. So 91 plus 67 subtracted from 180 gives me 22 degrees there. Now when I look at the big triangle, I have 67 and 25, and I can find the third angle. 25 plus 67 minus 180 gives me 88. For this to be angle, angle, I need two sets that match. Well, the 67 is in both triangles, but unfortunately 25 and 22 don't match, 88 and 91 don't match, so we're just going to call this one not similar. Now, saying it's not similar by angle, angle kind of describes the process we went, but that is the method we used to prove that it did not work. Moving down to the bottom left, I got two options here. I could make a reflexive angle and our little triangle, big triangle, and use side, angle, side. But instead, for this, I'm going to do side, 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 just out of preference. So side, 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 we're going to go 8 and 20. So 8 is to 20. Then 6 is to 15. As 9 is to 24. So those are our proportions for our sides. Let's see if we reduce them what we get. 8 and 20 I can divide both by 4 and I get 2/5. 6 and 15 I can divide both by 3 and I get 2/5. 9 over 24 I can divide both by 3 and I get 3/8. Well, these are not equivalent. They don't match, so this is enough to say not similar. For our last one, we're going to say first that angle W is congruent to angle W because that is the reflexive property. And we're going to say 15 is small side to big side, 45. And that's equal to 14 over 42. Now, both of these are divisible and reducible. 15 over 45 becomes 1/3, as well as 14 over 42. So that would be our scale factor. If we notice here, we've taken the small side and doubled it to get the larger piece. So we're going to go triangle WSV. Now we should go WQR. WQR is similar to triangle WSZ. And this would be by side, angle, side.